Yeah, good morning. Good morning, everyone. Good morning. Welcome to my PPT. Welcome to this PPT concept video. Before going to PPT or to present PPT, let me discuss briefly about myself. Uh, Myself, Bhuvaneshwar. As you can see, my roll number on the screen. It's 2195. You can see on my screen 027. I currently pursuing my BTech undergrad from Institute of Aeronautical Engineering under Department of from the Computer Science Engineering Department. This concept videos belong to the subject Computer Organization and Architecture. So without any further delay, let us move to the topic and let us discuss the topic. Yeah. First, introduction, like the topic which was assigned to me was introduction of memory organization. A brief like I'm going to give a brief introduction. What is the memory organization definition and parts, hierarchy of memory organization and levels of level different types, and in the each type different levels of them. We are going to briefly, like I'm going to the basic idea and the brief idea of the topic, which you can see. Okay, let us move into the topic. Next, let us see memory organization in computer architecture. Like, what is a memory organization in computer? Like, I'm going to what basic definition so you can understand. Before going to memory organization, let me define what does a memory mean. What does a memory? What does a memory mean? First, memory is an essential computer part. Like I didn't, it's a basic definition, so I didn't give in my PPT. Let me discuss what memory. Memory is a basic required computer part or computer component to store the data which we can perform the both read and write operation when is required. So I think you got my point. Memory organization, memory means, like, memory can be, we won't bother about the size of the memory, like it can be from bits to gigabytes or petabytes. Don't care about the memory size, but basic definition of memory is, it's a primary component of the computer which used to store the data when perform the operations of read and write whenever it is required. Like, there are specific memories which you can perform only read and which you can perform write, but basically this will be the definition which can perform both read and write operations. So as you got basic definition of memory, let us discuss what is memory organization in the computer architecture. Let me allow me to erase the screen. Yeah, see now, memory organization in computer architecture. A memory unit is collection of storage units or storage device. Like memory unit can be there is memory. If the collection of units combined together, memory unit is a collection of storage units of device together. The memory unit stores the binary information in the form of bits. Like even later, even with not, we still used to store the any information, whether it whether it was images or whether it was a content, video content, whether it is any kind of data, text format, video, image format, any will be stored in irrespective of the data in the memory. It will be stored in the types of binary information, which means 0 or 1 in the form of bits. Generally, memory storage is classified into two categories. Like we will broadly like most, there are many categories, but broadly we used to classify memory in the two types. One is volatile memory. What does volatile memory mean? Volatile memory mean this lose the data when power is switched off. Like it's mostly based on the capacitors. I am not going to discuss about this deeply, but it means when the current is switched off, power is switched off from the components of the PC. The volatile memory, in parts of volatile memory, the memory will be get exhausted. Where in case of non-volatile memory, this is a permanent storage. Like another type is non-volatile memory. This is a permanent storage and does not lose any data when power is switched off. Even the power is switched off, the storage is permanently stored unless and until you started the operation or you performed the operation to delete. The data won't be erased in the non-volatile memory. This is the major difference between the volatile memory and the non-volatile memory. I think so you got my point. Let me go to the further part of the PPT. Now, yeah, we got to know what does the memory mean, what does the memory organization mean. Let us see various like how they are categorized and how the memory hierarchy, so that how the internal components are placed, which will comes first, which memory unit comes first, like what are the uses and what are the cost, what are the advantages of this particular memory, what are the which is volatile, which is non-volatile. Based on all these calculations, we form the hierarchy of memory. Like hierarchy of the memory is hierarchy of suppose if there are operators which use BODMAS rule, which used to perform the hierarchy of operators. That is hierarchy of this hierarchy of memory. Like in hierarchy of memory, we deals with the memory, like where, like I will discuss briefly, but let's see the diagram first. In the hierarchy of memory, first we'll get register memory. If you are increasing order of access register, if you go from down to first, let's see the order: register memory, cache memory, main memory, magnetic disk, magnetic tapes. Last two are auxiliary memories. Memory disks and memory tapes are auxiliary memory. Auxiliary memory in the sense, these are the secondary device, secondary memory, secondary storage devices. They can be in the form of CDs or any HDD or SSD. This is auxiliary memory, means secondary storage devices. And third, main memory and primary memory. Primary memory, RAM, ROM, any type of RAM, any type of ROM. This is a primary memory. Cache memory, I will explain briefly later. Register memory, which the register memory means which used to store the temporary data in the CPU. Many registers, program counter register, or buffer registers. Many kind of registers you can use to see address register, data register in the CPU, right, in the processing unit. Like keep it part, but this is the register memory. This is hierarchy based on the various factors. First, if you want, suppose if you go from magnetic tapes from bottom of the hierarchy to the top of hierarchy, which is register memory, the access ratio time will be increased. Like see, access from register memory can speedily access, whereas in magnetic tapes you can't access that easily. The time will be increased, gradually increase from register memory to the magnetic tape. Whereas coming to the cost, magnetic tapes here will be low cost, but the register memory will be high cost. Like cost will be increased from here to there. So you got my point. Like this hierarchy will be useful to classify the data for the various types. According to cost, it will be increasing. According to for the performance, it will be decreased. Like it is a basic hierarchy. Hierarchy of the memory, like you can see on my screen. Once go to the hierarchy of the data, this is very important for the memory organization. Now let me raise my screen. Yeah, sorry. Yeah, now let us, as I discussed, still now I discuss the memory hierarchy, right? The whole about the how it's going to. I kept in the previous slide again. Let me show you once again. The total memory capacity of computer can be visualized by hierarchy of computers. The memory hierarchy systems consist of all the storage devices connected in computer systems, from the slow auxiliary memory to fast main memory. As this is, main memory will be slow, faster than even register will be more faster than the main memory in this order, and the smaller cache memory. Next, auxiliary memory can access time is great, generally 1000 times that of main memory. Yeah, you can see it's not that easy. Not, it's not time compatible for the auxiliary memory to the access. It's 100 times slower than the main memory. Yeah, hence it is the bottom of the hierarchy, as it is the bottom. It's access time, like to get the data from auxiliary, it takes more time. Next, the main memory occupies the central position because it's equipped to communicate directly with the CPU and with the auxiliary memory and device through input output processors. Like as we know from the input output peripheral organization, each and input and output organization have separate processor. Yeah, now again here, when the program not residing in the memory, it needed by the CPU, they are brought in the form of suppose if you want to use a program which is not in the main memory, then alternative, suppose if it's not present in the main memory, of course it won't be in any of the register, any of the cache memory, because main memory comes in the hierarchy after the cache memory and all this, right? So if you want to access the program which is not in the main memory, then they occur this situation to use the auxiliary memory or secondary storage device. Programs not currently needed in main memory are transferred into auxiliary memory. Even if you want to store the data which is not needed of main memory to access every time, so you can store it in the auxiliary memory to provide space in main memory for other programs that are currently in use. This is the basic use. Next, The cache memory is used to store program data which is currently being executed in the CPU. Approximate access time ratio between the cache memory and memory is to be 1 to 7 to 10. Yeah. Now you can see this is the basic organization. First magnet, like suppose if you see the CPU can directly access from the main memory and cache memory. The main memory will access from input IO processor, which is IO processor directly in connection with the magnetic tape and disk. Magnetic tapes and disks perform the same operation, which that's why we keep in the same level. But the way of the organization inside them is different. The way how they made was different. So these are broadly magnetic tapes and disks. For example, magnetic tapes means like you can consider it as an SSD. Magnetic disk means HDD, like which is to be always by using the spin rotation of the disk, it will we can access the memory. This is the basic organization. This is the basic organization which you can see. Yeah. Again, now let us see memory access methods. Each memory type is an collection of numerous memory location. To access data from one memory, first it must be located and then the data is read from the memory location. Following are the methods to access information from the memory location. Like there are many methods. One is random access. Main memories are random access memories. First, main memory is a random access memory in which each memory location has a unique address. Using the unique address, any memory location can be reached in the same amount of time. Like each and every different memory address. So that even it was placed in first or irrespective of place where they were placed, each and address has a same accessing time. This is the random access. Next is sequential access. This method allows memory access in the sequence or in order, like one after one. Like in this, the disadvantage will be accessing time for first is lesser, access for the last is bigger. That's the sequential access. Next is direct access. In other mode, information is stored in tracks, which each track has a separate, like each track is separate. This is the direct access. Now let us see what is the main memory. As we can see before, register means we know register means simple just to use in a program. But we know we have to discuss about the cache memory. Like I will discuss cache memory later. Before going to discuss cache memory, let me briefly introduce what is the main memory. Main memory. The memory unit that communicates directly with the CPU. Like main memory is the immediate predecessor of the CPU, which directly communicates with the CPU. Auxiliary memory and cache memory is called main memory. Like both, even we can even call both them as main memory. It is central storage unit of the computer. Even the main memory is central storage of computer. It is a large and fast memory used to store data during the computer operation. Many main memory is made up of RAM and ROM, with RAM integrated circuit chips holding the major share. First, main memory is again broadly classified into RAM and ROM. Let us discuss what is RAM. RAM means random access memory. RAM is a volatile memory. Like once the power is gone, it will be gone. It is a static again. It's static. It's a dynamic. Now let us see let us calculate RAM again. RAM is calculated DRAM, dynamic RAM, made up of capacitor and transistor. Like dynamic RAM is made up of capacitor and transistor. It must be referred every 100 to 1000 milliseconds. It is cheaper than the SRAM. Like it's most cheaper than the SRAM. SRAM means static RAM. Now let us see what is SRAM. SRAM is a static RAM, has 6 transistor circuits in each cell and retains data until power off. NVRAM, non-volatile RAM, retains this data even when turned off. Example, flash memo. Now again ROM. Let us after RAM we know ROM. ROM means read-only memory. Like now see RAM is a volatile, but read-only memory is non-volatile. It is more like an permanent storage for the information. It also stores bootstrap roller programs to load the start operating systems, which as you can source to start when you start the program, it loads the bootstrap, which is stored in the ROM. Next, if you want to classify the ROM, it can be found to programmable ROM, EEPROM, and EEPROM, electrically eligible ROM, and like I am going to not discuss about this in briefly. These are the types of ROM which you can prefer any internet articles to go them. These are different types according to the variation and as the technology passes, different types of ROMs came into know. You can mostly now we are using the EEPROMs and flash memories, so you can go to the internet and you can access them. you can get them. Now let us see the devices that provides backup storage are called. Now let us discuss what does an auxiliary memory mean. See, device that provides backup storage are called auxiliary memories. Like backup storage means if you are like every time the main memories will be less in space, right? To get the main memory, use auxiliary memory secondary device. For example, magnetic disks and tapes are commonly used auxiliary device. Other device used to as auxiliary memory are even we can use magnetic drums, magnetic bubble memory, and optical disk. It is not directly accessible to the CPU and is accessed using the input output channels. It's not directly, this auxiliary memory not directly accessed by the what is so called CPU. We should use an input output peripheral what we call so interference to access the data from the auxiliary memory. Yeah, let us discuss what does the cache memory mean. Basically the data or content of main memory that are used again and again. Like suppose if you want to use the data which some data in the memory, PC may use it frequently. Suppose if you want to access the data every time from the main memory, which it takes a lot of time, which requires more execution time. Instead of that, if you use a separate memory called cache memory, where mostly used data was kept in the cache memory, like we are going to implement cache memory by various algorithms. It may be LIFO, last in first, or the least recently used algorithms. There are various algorithms which cache memory was implemented. By using the cache memory, which we can share the time by execution, by reducing the execution time by searching near in the hierarchy. So the data or content of the main memory are used again and again by CPU, are stored in the cache memory, so that we can easily access the data in shorter time. Whenever the CPU needs to access the memory, it first checks the cache memory. If the data is not found in the cache memory, then the CPU moves on to the main memory. If it also transfer the block of recent data into the cache and keeps the deleting old data in the cache to accommodate the new one. This is going to be how cache memory is going to work in the PC. Now let us see let us define what does the hit ratio mean. The performance of cache memory is measured in terms of quantity called hit ratio. So let me see, every time hit ratio mean every time you are going to first it will going to search in cache memory, right? Suppose most of the times if not getting the data from the cache memory, it means that hit ratio is very less. It means it should be more number of successful searches in the cache memory to increase the hit ratio. Hit ratio just describe the cache memory successfulness, which means when the CPU refers to memory and finds the word in cache, it is said to be produce a word is found in cache memory. If it is the main memory, then it counts as miss. The ratio of the number of hits of the CPU refers to the memory is called hit ratio. Hit ratio is equal to hit divided by hit plus miss. Suppose if you got hit ratio 0.9, it's good, like 90% of the data are going to be successful in the cache memory. Now let us see what does the associative memory mean. It is also known as content address memory, CAM, or contents address memory. It is memory chip is which each bit positions can be compared. Like we use key concept, which like I am not discussing about this, which use key various comparisons. In this, content is compared in each bit cell, which allows very fast table lookup. Since the entire chip can be compared, contents are randomly stored without considering the memory address schemes. These chips have less storage capacity than the regular memory chips. Like even the associative memory have less than the regular chips. Now let us see memory mapping and concept of virtual memory. What does the memory mapping mean? See, memory mapping means the transfer of data from main memory to the cache memory, is referred as memory mapping. Like we used to call mapping means how transformation data from main memory and cache memory is going to occur. There are three types of mapping. One is associative mapping, direct mapping, and set associative mapping. I will discuss them briefly now. What does the associative, direct mapping, set associative mapping mean? Now, direct mapping means the CPU address of 15 bits is divided to two fields. In this, that 9 least significant bits constitute the index, and the remaining 6 bits constitute the tag field. The number of bits in index field is equal to number of address bits required to access the cache memory. This is the direct mapping. As you can see, in the total 15, let's first 6 bits they contribute for tag, and next 10 bits for index. We used to compare the tags, and we will get we will start indexing direct mapping. The CPU address of 15 bits is divided into two fields. As you can see, the 9 bits is significant bits are considered index, and remaining 6 are for tag field. The number of bits in the index field is equal to number of address bits required for the caching memory. Now let us see what is associative mapping mean. The associative memory stores both address and data. As you can see, the address of the value of 15 bits is 5 based local octal number, and data is of 12 bit odd and 4-digit octal number. A CPU address of 15 bits is placed in argument register, and the associative memory is researched for matching address. This is going to be a block diagram for associative mapping. You can refer the diagram, and you can proceed with associative mapping. Now let us see what does set associative mapping mean. The set associative mapping, the disadvantage of direct mapping is two words with same index address can't reside in the cache memory at the same time. This problem can be overcome by set associative mapping. In this, we can store 2 or more words of memory under the same index address. Each data is stored together with the tag and its form set. I can say tag, and there will be data set and address. By mapping the tags in the data set, we will fit the address. This is going to be set associative mapping. Okay, I think so. I gave a brief introduction about the introduction to computer organization, introduction of computer organization. I think so. We got what does the computer organization means. Thank you.